All right, so you guys know about programming assignment number 1. It has been released. And if you got any question about it, you can feel free to reach out to myself during the office hour. More than happy to help you. It will be, for example, today, 3 p.m. to 4 p.m. Also this week, Monday to Thursday. Just drop by. And I will also launch the Zoom link. So if you want to talk to me virtually, that's definitely fine too. Okay, but sometimes it might help if you just drop me a brief email shortly before the office hour. So I can expect you to connect through the Zoom. Yeah?
Is it released in your e-class page or the all section e-class page?
You mean the contact information?
No, the assignment.
The assignment, it's in the common e-class site. So that's not the one for X and Z, the one for M and XZ. Okay. Yeah, if you cannot find it, let me know. Should be very straightforward.
Will there be answers posted for the assignment?
Yes, indeed. The question was, will there be solutions posted? Even better, if you don't mind, I also got a solution video for you guys to really walk you through the solution. All right, so guys, just focus on your learning. Do as much as you can, either by yourself or maybe collaborate a little bit with your friends, fellow students in the course, and then kind of pinpoint exactly where you struggle with the recursion. And once I release the solution, take a look and also reach out to me about the solution. And the contact information for the TA, you can also find them in the e-class site. I think the TAs are ready for your request. It's on demand. Okay. All right, guys, any question about the course in general? All right, very good. So let's do a very quick recap. We haven't covered that much just yet, but it might be worth recapping about what we have done so far. So last time, we basically just talked about the 3 motivating problems about searching. And as a promise, we'll definitely get to balanced binary search tree after the reading week as we started talking about trees, which will be definitely the focus for this course. And we talk about the compilation problem, about compiler, right? You guys can refer to the lecture. I may not repeat many details over here. All right, so we started kind of review about the basic principles of recursion. So very quickly. So the principle that we're going to follow for both easy problem and also difficult problem will just be the same. So if the problem you're given is small enough, it's so-called a base case, in which case you can program or return the value for the base case right away, which we'll see. If you're given a problem that's kind of way too big for you to solve right away, so this will be something called recursive case, which is like an inductive cases in your mathematical induction, right? You can also refer to the lecture for the connection. Let's say I got a problem that's way too big. The way to do it is something called divide and concur. Divide would be to divide the original big problem into several, at least one, several strictly smaller problem. You can have subproblem number 1, subproblem number 2, subproblem number 3. And the interesting bit about the example that we're going to go over today about split array, you got more than one subproblems to think about. We'll see. So you got each individual strictly smaller subproblem, and then you're going to assume you got solution for each one of them. The way you assume this is by simply making a recursive call in Java, which we'll see. You simply assume that the recursive call I'm making here is going to return back to me the correct result for the subproblem. That's something you're going to safely assume with confidence. But when we do the tracing to see what's really happening behind the scene, you will see all the tricky stuff has been taken care of for you behind the scene at the runtime. We'll see. And then once you got the individual subproblem solution, you can combine that into the final solution. So this pattern here is really, really fundamental. Really keep that in mind for your reference, right? So whenever you got any challenging problem there, if you got enough time to think about, to sketch a solution, always think about this pattern here. All right, we shall connect to this problem here, this pattern here a little bit later today. All right, we talk about call by value or pass by value, depending on how you were taught, maybe in the previous course. But the idea would be if you want to run recursion on a single array, there is simply no need for you to create any separate array to waste the memory or waste the resources. So what we'll do instead is to make sure only one array is kept in the memory. So every time when we are trying to make a recursive call, making another recursive call, they're always referring to the same array reference, always, right? That's call by value. So I'm going to leave you guys to really catch up with what call by value really means. If you got trouble, let me know. All right, so there's a pattern we're going to also use today. All right, so that's the illustration we kind of talked about, some simple one about call by value last time. And this is the last page that we started with last time, just briefly. So I assume everybody knows about the split array problem here. I may not repeat. And I talk about how that can be kind of connected to this mathematical problem that you studied back in 2030, Math 2030, right? We talk about how you can figure out exactly the solutions. And this is exactly how we're going to see when we try to trace the code. That's something I also try to give you guys some practicals today. So today might be the very few occasions I have to use Eclipse. But you guys can watch the recording later to reproduce what I say. So feel free to focus on what I'm going to do in the Eclipse. I'm going to spend quite a bit of time in the first half. All right, any question from last time? Good, all right. So I'm going to revisit this guy here pretty soon. But before that, let's see where we got. OK, over here. Let me say very quickly. So this guy over here is actually talking about the different decisions we can make to say, OK, let's say this. If the example that we are talking about is an array 2 and 3, so we somehow have to consider 2 and then consider 3 intuitively. So what we're going to see in the tracing later is we start with this initial starting point where we got group number 1 and group number 2. They're simply just empty to start with. And then from here, you got two possibilities. Either you can say, I want to go ahead with the assumption that the number 2, which is the first element over here, is going to be put into group number 1. The separate but independent branch is going to assume I'm going to put the number 2 into the other group instead. So this kind of like splitting the single element into either group number 1 or group number 2. We're going to repeat this pattern for every level. So that's why you can think about what's going to happen is for number 2 here, it can be put into either group number 1 or group number 2. Also for 3 here, it can also be put into group number 1 or group number 2. Altogether, how many possibilities do we have? 2 times 2, which would be 4. All right? So that's why you actually got this particular, I call tree here. I'll give you more detailed tracing in a moment. So you can think about this will be possibility 1, possibility 2, possibility 1, 2, 3, and 4. So 4 possibilities, right? So that's kind of the intuition you want to have for this particular solution. I'm going to write down some insight that you guys may want to think about after today's lecture. And you want to really dive deep into this example here. There are many things we can learn. All right, so the insight I'm going to put here, I'm going to do some textual, and also I'll draw some diagram just to show you before we see some concrete tracing. So the recursion pattern that we're going to learn from this split array example here will be, let me put it here. Okay, so the insight. Okay, the recursive and base cases. The recursive and base cases, which we shall see when I show you on the Eclipse. I'm going to develop from scratch together with you, are defined such that the tree, and here let me emphasize about the tree. I know we haven't really formally introduced about the concept of a tree, but you can easily actually just get some intuition. So let's not bother with any formal definition. You basically got one thing here and branch out at every level. Of the tree of runtime recursive calls. Represents, this is important, an exhaustive search of all possible input scenarios. However, this one here, I want to mention something here which I will also illustrate to you. The exhaustive search I mean over here is really just a worst case, but not necessarily for every case. In many cases, especially if the output happens to be true, very likely the algorithm is actually more efficient than you think, which I will show to you. And the way we're going to do that is by something called short circuit evaluation. You may have heard about this term maybe from the second year or first year, which I also showed to you. All right. Okay, that's the insight I want you guys to think about. You may not really appreciate it very much at this point, but maybe after you have dived deep into the example, you can appreciate this insight more. And let me now give you some overall picture. The way we're going to trace is going to be something like this. It's going to be a tree. So think about this is like a tree, right, over here. So the top level over here is going to be the first call we are making. This will be the first call. And the bottom here is going to be all the base cases that we're going to face. Base cases, which will return either true or false, because the method itself returns a Boolean. So here, the bottom level base cases will be all just about returning true or false. What about in the middle? In the middle here, it will be all the intermediate recursive cases that we're going to see, right? Non-base cases, which will be just a recursive call. That's the overall picture we're going to see, right? That's going to be true for any input you're going to pass to this method here. You're going to follow this pattern here. But we're going to see some concrete example. All right, any questions so far? All right, so let's now dive into Java a little bit. So let me program the solution together with you. And I'm going to follow my version of solution, but you can feel free to maybe discuss with me about your own solution, maybe during office hour. We can definitely talk. The way I'm going to define may not be the only way, but it's definitely a reasonable way to do things. All right, let's now switch to Eclipse over here. All right, so what I started you guys with was to say for this method here, which takes an input array, I simply say return false. Beg your pardon. I just say return false by default. And then I got some helper method here. Let me explain very quickly. The method here is going to take call by value the input array, just the same array. And this I here is going to be some array index. You can think about as soon as I becomes too large. Let's say the input array is of size 2. What will be the first index that's becoming too large? 2. Because 2 cannot be a valid index for array of length 2. Right? It should be only 0 and 1. So as soon as, for example, I gets to 2, in this case, we know that we are reaching kind of the end of inspection for all the elements to put into some groups. And at that point, we should really decide, should we return true or false for the base case? And the next two input parameters here is really a way for us to somehow keep track about our decision. Should we put the current element at index I into group number 1? Or should we put the current index at element at index I into group number 2, right? We're going to do that accordingly. All right, sorry, my mouse. There we go. All right, so these are the two integers, but we're going to see. All right, so let's now program the solution. Okay. Oh, just before that, so what about over here? So you want to draw some connection between this recursive helper method, which is private. You want to somehow use it in the public method here. All right, so the way we're going to use it, let me write this line first. You got to call that. So split array helper is going to be called over here. And the typical way to really scan through the array, first of all, let's put the array reference. It's going to be NS, right? You can see the NS corresponds to the NS over here. And then what should be the starting point? Well, let's say we want to go from left to right. We want to go from index 0 all the way to ns.length minus 1. Or if you want to try, you can also go from right to left. That's also possible. I can leave that to you as an exercise. Start with 0. All right, index 0, the leftmost index. And then initially, remember what we said earlier, initially, we're going to have the group over here both empty. So this one should be empty, this one should be empty. That means their sum should be both 0. All right, so hopefully you can see that correspondence. And then let me go back here. I'm going to put 0 here and 0 here. All right, so that's how we make the call for the very first time. We haven't got any recursion just yet, but we will. And then over here, we're going to program this method here. And the pattern tells us we should really have base cases and recursive cases. Okay. So base case would be, since we're going from left to right, as soon as we have reached the index that's too large. So let's say I over here, if that's simply equal to ns.length. That's too large. All right, so I'll write a comment here. That means all elements in the array have been inspected, or they have been somehow put into groups, either group number 1 or group number 2, right? And at this point, we can expect the sum here and the sum here somehow have accumulated certain values. For example, let's say here, if you're in this particular base case, let's say over here, in that way, the sum for group number 1, that integer should be 5 versus 0. And now we should just compare them to see whether they're equal. If they're equal, we return true just for this particular base case. If they are not equal, which is this case over here, 5 versus 0, then we should return false for that particular base case. All right? All right, so let's now go back there. And then we're going to say, and the base case is incredibly easy. We just say return sum of group 1 equals sum of group 2. That's base case. As easy as that. And one more thing to say, you can say that base cases correspond to the bottom level of the tree. Right? What I meant was, each base case is going to be base case here, base case here, base case here, base case here. All right, bottom level. That's what I meant. And let's now try to talk about recursive case. Right? Let me write down. Let me do a little bit like a sketch here. We basically got two possibilities. Right? Let me write some comments here. Let's say possibility number 1. Since we are currently inspecting element at index I, ns I is placed into group number 1. That's possibility number 1. Group number 1. In which case, we should really update sum of group number 1 if we want to go further, right? Because if we want to put NSI into group 1, sum of group 1 should be incremented. And sum of group number 2 should remain the same, right? In which case, sum of group 1 should be updated. Okay, there's another possibility which I'm going to write down over here, and then I'll write down Java code. It's placed into group number 2, symmetric, in which case sum of group number 2 should be updated. And now our job is, how can we somehow translate possibility number 1 into a line of Java code, and also possibility number 2 into another line of Java code. All right. Each one of them is going to correspond to a recursive call to this method over here. Okay, I'll start you with a little bit. The easy part I can do for you. I can say, let's say this, call that, call by value. All right. So if I'm trying to make a recursive call, that means I want to look at the next element, assuming that I have already put NSI into group number 1. How can I say I want to go to the next element next to I plus 1, right? Okay. You're still struggling, that's absolutely fine, but you want to think about it maybe after today's lecture, I plus 1, right? I want to go to the next one. And since now we're talking about possibility number 1, in that case, I should really only update sum of group number 1 and keep the sum of group number 2 the same, right? Sum of group number 1 plus what? NSI, thank you, all right. And then the other one should be sum of group number 2, all right. Guys, let me pause here a little bit. This is really important. Line number 16. The code doesn't compile, doesn't matter for now, okay? I want to make sure you understand this line. Any questions? All right. And what about possibility number 2? Let me just copy that and put in the next line. All right. Now, what should I change? Go ahead.
Change it from to some group 2 plus NSI?
Thank you. Yeah, because in this case, since we're assuming that we're going to put that into group number 2, so we only update group number 2. All right, as your fellow student said, that's exactly correct. So I'm just going to cut this one here and put it here. All right. So you can see these two recursive calls kind of correspond to the following. If I'm here, I'm going to make two recursive calls, call number 1 and call number 2. If I'm here, I'm going to make two recursive calls, call number 1 and call number 2. It's like the branches, the way you branch out. All right. However, the code doesn't compile. Too bad. Let me now remind you something very important. Remember the general pattern I spoke about in the beginning when I did a recap. Let's make some very important connection. The two possibility, like a two recursive call I have, is like the two green boxes over here. They are like solution number 1 and solution number 2. But somehow you cannot just take the two solutions and say they are the solution for the original big problem. No, you cannot do that. What you got to do is you have to somehow massage or combine them into a valid solution for the original problem. That's what's lacking. All right. Let's now go back there. Now, what should we do? Line number 60 over here is like a method call to a method which returns Boolean. I got one Boolean. So here I got another Boolean. I cannot simply say I got two Boolean values for a method that's expecting just one Boolean. I should combine them somehow. So you guys learned about logical operator in Java, right? You got two possibilities, for example. Either you want to use ampersand, or you can use vertical bar. Which one should I use? Yeah. Vertical bar, that's like an OR operator, but why not the ampersand? You just want one of the conditions to be true, right? So remember, now we are finding just at least one group splitting that's equal. We don't require every possible group split to be equal. So that's why it got to be an OR operator, right? So making a decision about which operator you use is also very important. If you use the ampersand, it's going to be wrong, all right? So what I will do here is I'm going to connect, beg pardon, vertical bar here. And then I'm going to return. The whole thing is a Boolean. All right. Now everything compiles, but let's not be too satisfied just yet. Hopefully, all the test cases will just pass. Okay. There we go. All right, remember, it was only half passed when I first illustrated to you, but now, since we got a correct solution, now everything passed. All right. So now I think this will be only the beginning part. I think you guys deserve to know a lot more about what's happening here. So what I will do is I'm going to go over the code structure with you a little bit, and just to make some more annotation, and then I'm going to trace it together with maybe some simple case. I'll also give you one like a slightly more complicated example for tracing. You guys should really try. And when I do tracing, I want to do both on the paper and also on debugger for Eclipse, which you guys also very much needed for your programming assignment and the programming test later. And then I'm going to conclude this example here with a even more complicated input and try to draw some general picture. All right, we'll see. Okay, one thing at a time. First of all, let's now go back to the code that we have just seen. The code I just developed together with you was just this guy over here. All right, just here. Let's now just review certain facts about this implementation here. And I'll make some annotation, and then I will, let's go from here. Okay, there we go. Before we do tracing. Okay, good. Okay, first of all, you want to realize that, number one, you can see this method here is public. That's the only method that user is going to depend on. The user should not be bothered by anything other than input array. Any extra parameters are only private to the implementer, the programmer, which is you. So you can see that here, the private here is really important. Okay, okay, and we talk about the 0 over here. So this will be the starting index to inspect. And the convention is you go from left to right. And you can feel free to modify the code such that it will go from right to left. It's also doable. All right? And then we actually say 0 and 0 over here. This one simply say empty groups in the beginning. We haven't put any elements into group number 1, group number 2 just yet. So just empty. So that's why the sums are simply both 0. All right, that's why you should really understand. And then let's now take a look at these guys over here. All right. So I'm going to just explain the big picture about what's happening here. Let's focus more on this guy here. All right. Let's now visualize this a little bit. So we got NS, which is an array in general, is going to be actually index 0, index 1, and there might be some intermediate index I, and then the next one, of course, will be I plus 1, all the way to the last index should be ns.length minus 1. Right? That's the general structure for an array. So the base case is very easy to see. If I here is exactly equal to ns.length, which is outer boundary, in that case, we know we have inspected everything. In that case, we simply compare if the sums are the same. Right? That's the base case. Let's now focus more on this guy here to see exactly how we visualize the recursive pattern here. Right? So you can see at the moment we are at index I, which means we are looking at this particular index, this element here. And we are thinking about whether we should put the orange element into group number 1 or group number 2. That's what we're doing, right? So you can see basically somewhere in the tree. So we are talking about in the middle of the execution, right? So here we actually got some, I would say, split array helper, SAH, just for short. And then over here we got NS, the reference to the array called by value. And we got I here, which is the current element we are looking at. And also we got the sum of group 1, sum of group number 1. And also the sum of group number 2. This is where we are. And we are thinking about how we can go further. And the way we do it is we're going to think about two possibilities. Possibility number 1 and possibility number 2. And since we are now thinking about index I over here, so there are two ways. So either NSI can go to group number 1, or NSI can go to group number 2. Either way. Okay? In the case where NSI has to go to group number 1, that means in order to really go further, we have to make the assumption that NSI has been already accumulated to this value over here. Right? So that's why the way to really make that recursive call is split array helper. NS, and now we got I plus 1. Meaning that in order to really handle the next element, we have to look at the next element, right? That will be for the next one, not the current one, the next one. Okay, I plus 1 is basically here. And then, since we are going to put that into group number 1, so that means we're only going to update the sum of group number 1. So the sum of group number 1 is going to be be incremented by NS I. Whereas the sum for group number 2 will remain the same. The sum of group number 2 will remain the same. Okay, so this will be 1 here. And then we got to do another one. Okay, let me be a little bit lazy. Let me just move this guy here a little bit so we got enough space. There we go. All right, for this guy here, this part here is no longer the case. It should be symmetric, right? And we are saying that because we are moving that into group number 2. So this part here, so the sum of group number 1 should remain the same. Whereas since we are accumulating MSI into group number 2, the sum of group number 2 plus NSI. All right. I guess okay. There's a little bit more visual, right? You can see exactly what we're doing. And notice that this kind of branching into possibility number 1, possibility number 2 will be the same for as deep as is necessary until we reach the base cases. And independently, this is a Boolean, this is a Boolean. We somehow have to combine them using the OR operator, which is over here. All right, you can see the operator over here. So we think about we are combining them using OR. I'll put OR here, just remember. Okay. All right, any question so far? Yeah, yes.
So I'm just like I want to clarify the order that it's like
about evaluating this, I'm getting to it right away. Yeah. So Robert's question was really about with this OR operator over here, how exactly are we going to evaluate, right? Let me just interrupt a little bit just to brush up very quickly about short circuit evaluation. So you guys learned about math 1090 or 1019. So in math, there is something called commutativity. For your information, commutativity. For example, if I say P and Q, and also Q and P, they are equivalent. And also P or Q, Q or P, they are also equivalent. That's math. However, in programming like Java, there's no commutativity for efficiency reason. That's why we got short circuit evaluation. So in Java, you got to watch out for this. Evaluation order matters. Meaning that if I say P ampersand ampersand Q versus Q ampersand ampersand P, they are not necessarily equivalent, not necessarily, all right? Similarly, if I say P or Q, and also Q or P, you know, or is one thing we're using, but I'll just mention M anyway, because you might need it. They are not necessarily equal to each other, not in general. All right, so let's now review exactly how the execution is going to happen. So here would be the principle, okay? The principle number 1, the evaluation is going to be from left to right. Evaluation at the runtime, I meant, right? Let's say at the runtime, you want to evaluate what's the value for, let's say, this expression. What's going to happen is I'm going to evaluate P first. If necessary, I will evaluate Q as well. Left to right. All right. And then let me call this one here 2.1. And let me call this one here 2.2, right? So I can talk about these two. So I'm not going to trouble you with any question here. I'm going to tell you right away. We know that in order to define AND, in order for that to be true, both of them should be true. If I know that P is already false, do I really need to evaluate Q? Not really, right? I can already return false right away, all right? So for 2.1. If P evaluates to true, that means you also evaluate Q. If P already evaluates to false, skip the Q, and the overall evaluation is going to be just false, right? Because false and anything will just be false. All right, so this case over here is for 2.1. All right, any question about 2.1? All right, let's talk about 2.2. 2.2. All right, so 2.2, I'm going to put it here. You also got to evaluate from left to right, left to right. If P evaluate to false, for example, in that way, if this is already false, but I still have a chance for the overall expression to be true, because if Q happen to be true, then the overall expression can still be true. So I have to evaluate it. Also evaluate Q. However, if P evaluate to true already, if I know that this is already true, doesn't really matter what Q is. Overall will be true anyway. So I can save some computational time by skipping this. All right. Skip Q, and then overall, it will be true. It's a very quick reminder about these two logical operators. So you might need either one of them or both of them for your recursive methods later. But for this split array example, we only need the OR operator. And this short circuit evaluation, let me just tell you very quickly, is very useful for efficiency. Let's say this, P or Q, right? I'll give you some very quick look ahead, which we're going to see as well. You can see here we are saying this recursive call or this recursive call. Let's say if this recursive call, which has to be evaluated first because that's on the left, if this already tells me true, do I need to bother to figure out all the possibility on the right branch? I don't need to, because in that way I can return true right away from here. All right, so that's something you want to also get as an insight. Even though conceptually I really think it would be necessary for you to understand the recursive calls are really trying to enumerate systematically all the possibility for the input scenario about grouping the numbers. But at runtime, it's very likely, since we're using short circuit evaluation, as soon as we find some true evaluation from left branch, for example, in that way, we will return true right away. We don't even need the right branch. Right? I'll make it more concrete as I trace one example together. All right, so this page here, I just want to go over with you just about more design logic of this recursive helper method. We haven't done any tracing yet, but we'll do. Any question? Yes?
So yeah, I just wanted to ask that because that dictates like, well, it's not search, but I guess you would call it like breadth first instead of depth first.
I wouldn't get into breadth first or depth first, maybe because that would be more about 3101. Let's not worry too much about it.
I'm just saying the order they're called.
The order is just from left to right. Yeah.
This is just a question about the problem because it came a little late, so just to understand it. So we're taking an array, an integer array, which has, and then we're putting each index into two different,
Yeah.
two integers.
Yeah, exactly. So for example, over here, if we are currently considering the element at index I, what we are considering is we can either go to the left branch where this element has been put into group number 1, or we can go for another independent branch, which is possibility number 2. In that way, we are putting that element into group number 2. So as long as one group is going to work, we're happy overall. But because of short circuit evaluation, if the left group already works, you don't need to go to the right group. Okay? Yeah. Yeah.
Could you just explain the return statement for the base case?
Yeah, of course. The base case is like this. So you can see that for every call, we are just keep plussing 1, right? So every time when we see I here, that means we're currently looking at this particular element. So when we go from I plus 1, the very last call with the valid index will be ns.length minus 1. However, from there, we also get a plus 1. So ns.length minus 1 plus 1 will be ns.length. So that's really the last call we're going to see terminating, which we'll also see when we do the tracing. So once we get to ns.length, we know that we have already considered all the elements in the array from left to right. So that will be the place to really terminate and decide whether we want to, for example, here, let's say we go, think about this is about index 0, this is about index 1. And then when we get to over here, it's going to say, now I want to consider index 2. But there's no index 2 for an array of size 2. So that would be the way where we have to return from the base case either true or false. Yeah. All right, any other questions? All right, so let's now do some tracing. And I would suggest I would definitely go for Eclipse. I think that's really fundamental. But let me now do some warm-up together with you. Because the way to trace recursion, which I can do maybe slightly more complicated example with you during the office hour if you find the need. But for the class time, I can only do some very simple one. But I'm pretty sure that one can already get an idea. The way to trace a recursive call in Eclipse is actually quite tricky, in the sense that you can easily lose track. You're basically calling the same piece of code. For example, the definition for the recursive helper method is just like that. So you're going to call this piece of code for many times for every recursive call. You have to know where you are in the tree. So the way I'm going to show to you is how I will recommend you trace your code by using something on the paper, which you will sketch first, and then on the Eclipse. All right, let's do that completely. All right, so let's now talk about one test case. You can take a look at test split array 01. That's in the JUnit test class, right? Let's trace this one. Very simple, 2, 2. Let's do some very look ahead thinking, even before I write down anything. How many possibilities are there overall at the bottom level? 4, right? Because for this 2 over here, it can be put into either group number 1 or group number 2. For here, it can also be put into group number 1 or 2. So 2 to the power 2, 4. All right? Let's now try to write down exactly the tree. All right? And then we'll go from there using debugger. Okay? So what I will do is I'm just going to, you can see that we are calling the method right here, split array. So this is the starting point, split array. Okay? So here we got split array and then ns. That's the starting point. That one there is actually going to call the method here. So wait, let me say it again. I think this will be better for you to understand. Let me start from scratch. This test case is going to call split array, which is going to go to here. So this will be the starting point. All right, so this is our starting point. So we got split array and then ns. And that one there is going to call split array helper, ns 0, 0, 0. So that one there is also going to branch out, just one branch, right? Split array helper, ns 0, 0, and 0. All right? Okay, let's now watch out. And in order to execute this, is this the base case? Well, you can see I, which is 0, is it equal to ns.length? ns.length would be 2. No, 0 is not equal to 2. So this is not the base case. All right, that's how I judge. And then, so that means we have to really execute this block over here, which is going to branch out. So this one here is going to branch out to over here. Hopefully there'll be enough space. And also branch out to over here. So this will be ns0. Okay, let me draw ns over here, just in case you need some more visualization. So ns, index 0, index 1, we got 2 and 2. All right, 2 and 2. All right. So ns0 would be this element here. Okay. It might go to group number 1, or it might actually go to group number 2. And we're going to combine the two results using OR. All right. So we're going to make the first recursive call over here. Right. That one there is going to be ns. So it's going to be, helper, SAH. All right, so we're calling this method here. And then we're still passing ns. And now I plus 1 will be 0 plus 1, which will be 1. All right, and then this 0 here should be updated by incrementing 2, right? Because we're putting that into group number 1. So this will be 2. And then the sum remain to be 0. All right, guys, you try. What about the other case? SAH and then NS. Give me 3 numbers. 102. Okay, I like that. Pretty easy. Right, you can see it's really symmetric. NS the same, and then we're still putting I plus 1. And now, rather than 2, 0, it's going to be 0, 2. Because we put that into group number 2. All right, we're kind of halfway. Let's now be very complete. And then for this one here, it will also branch out. So far we are done with considering the very first element. You can think about ns0, that one has been done. Let's now considering the second element, which is at index 1. And that one there is actually going to be, so SAH and then ns. So now we got two choices. Either it would be that this element here, so ns1 can be put into group number 1, or ns1 can be put into group number 2, right? And then, so here, guys, what should be the next number after ns? 2, right? Because now we already have 1 here. We're currently looking at element at index 1. The next one to look at would be index 2. So this is crucial for you to identify. Okay, any idea how to put the next two numbers? 40, okay? Because now we are saying that we are going to put the element here into group number 1. So accumulate it here. So 4 and then 0. All right, you guys kind of see the pattern, right? So I'm not going to trouble you. Let me write down. And then we have to move on to Eclipse pretty soon. So split array helper, and then we got ns, and also we got 2 here. So it's going to be 2 and 2. Would you agree? All right? Because if you compare this one here and this one here, so this one remained the same, but now we put 0 accumulated with 2 because we decided to put into group number 2. All right? Let me also finish that guy here, which is going to follow the same pattern. That one there is going to be ns1 put into group number 1. ns1 that'll be put into group number 2. Let me finish that. And then ns and then 2. So now this will be 0, 4. Oh, sorry, 2, 2. Because we're going to put this element here into group number 1. So that'll be 2, 2. Okay, so let me just write it down properly. 2, 2. There we go. And then this one over here, and S, and then 2, and then 0, 4. Well, you can double check. You can also try to construct this tree yourself. And would you agree, each one of these is a base case? Because you can see now the 2 here, the 2 here, the 2 here, and the 2 here, they all correspond to the length of the array. So we're matching the base case for each one of them. So for each one of them, we're going to return either true or false, right? All right, so for this one here, it's obvious we're going to return false. Because 4 and 0, they are going to fail this one here. So it's going to be false. And then for this one over here, it's going to return true because 2 and 2. Also, for this one over here, it's going to return true, 2 and 2. And also for this one over here, it's going to return false. Tedious, but it's required. Right? You really need to kind of dive into such complete details to really see how things work. And of course, each one of them will also be combined by the short circuit. So this one here, and also this one here. All right. Before I kind of move on to the debuggers, I want to do 2 things. Number one, if you think about how evaluation is going to go at a runtime, let's do a little bit mental exercise here. In order to evaluate this one here, I should really evaluate this one first. In order to evaluate this one here, I should really evaluate this one first. And this one here already returned to me false. So I go back to here. I still have a chance to return true. So I evaluate another branch. And this one here is going to return to me true. So I know that this thing here is actually true. And then I go back to the original recursive helper method here. That one there is going to give me true. Do I still need to go ahead and evaluate this? I don't need to because of short circuit evaluation. If the left-hand side, if the left branch is already giving me true, I don't need to go any further for the right branch. So it's not that inefficient as you might imagine. But conceptually, again, you want to know how to enumerate all the possibilities. In some cases, especially if the result is going to return false, you still have to examine all the possibility to know that there's no such true case for you. So you still got to exhaust all the possibility. All right, so now for number 2. To really make sure you don't really get lost, because I'll try to be as quick as possible for debugger. but you got to be clear. Let me number the steps we're going to go through in the debugger. All right. So this is going to be step number 1. This is going to be step number 2. And then this will be step number 3. And this will be step number 4. And then because it's going to return, so we're going to return back to this method here. So I would say number 5. And then we're going to evaluate the right-hand side. So this will be step number 6. And it's going to return to the same thing, step number 7 here. And then we're going to return back to here. That'll be step number 8. And then finally, we got into step number 9. I'm going to show you exactly how to see each step. So we will never get a chance to really get to the right branch for this particular input. So that means it's quite efficient. We only have to consider half of the tree. That's the main point I'm making. Right? Let's now give it a try. All right, I'll try to correspond to it for every step. Okay. Okay, how do you use the debugger? Right? That's something I kind of assume you guys kind of did. If you don't know exactly how to do it, I do have some reference for you on the slides, but you can also reach out to me during the office hour. Okay. Let me now actually put the one I'm looking at is split array 01. I'll put a breakpoint in line number 15 over here. So that's actually around the place I'm going to call this method here, right? Call the input. So what you do is you're just going to, there are 2 ways. You can simply click on the box button here, or you can right click. Let me show to you. So you can go to that JUnit test class, and then right click on that. And then you're going to say debug as JUnit test. That's another way to do it. All right, let me do that way. And then it's going to prompt you to say it wants to switch to the debug perspective. I'll say switch. Okay, I'm now in the debugger. All right, it's being launched. And then it's going to highlight this current point here. It tells me that the runtime execution paused at line number 15 right before I try to execute this line, right before I execute assert equals. So what I'm going to do is I'm going to keep doing 2 things. Either something called step over. You will see different arrows over here. So there are 3 arrows here. Either step into, step over, and also step return. All right? I'm going to use all 3 of them. But for the very detail about each of these, you can definitely also refer to the references, but very briefly. Step into means I want to make some method call. I want to see inside the method call. I say step into, go into the method. Step over simply means I want to go 1 step at a time. If the current step is simply a method call, I don't really go into it. I just execute the method and go to the next step. I got a step return. That means I want to skip the current line. Okay, sometimes you may have to use it. All right, so now my goal is I want to go into the execution of split array over here. So I would say step into. All right, so this, don't panic. So if you try this on your machine, this might be what you were seeing. Somehow it has not been linked to the JUnits library, which is okay. So this will be the occasion you can try step return. So there, the rightmost icon here is called step return. If I do that, I'm back here, and then I'm going to try once more to say step into. Then it's going to switch the context into split array. All right, step into. So now I'm here. Right, so now this will be step number 1. So I'm going to remind you, I'm now exactly here. This is the place where I'm trying to call this method here, step number 1. All right. And I want you to, sorry, it's a variable is a bit small. All right. So here, and when you actually watch a recording or maybe try to do it yourself, you can, the way to really keep track of where we are in the tree, you have to look at the variables here as well, especially about I, the sum of group number 1 and sum of group number 2. That's the best, most effective way to keep track of where you are in the tree. I'll show to you. All right, keep track of variables here. All right, so we are now here, and then I'm now going to step into. If I say step into, I'm going to step into array helper, split array helper. Right? Okay, I'm now in split array helper. And these are the 3 things I want you to look at later on. So I got I here, I got sum of group 1, and I got sum of group 2, 0, 0, 0. So the 0, 0, 0 over here correspond to the 0, 0, 0 here. That's where you can identify where you are in the tree. That might be the most effective way. So now we are in step number 2. We are here. And we know that according to definition, from here we got either possibility number 1 or possibility number 2. So we're going to see exactly how we can keep track, right? Just watch out. So the base case, we know it's not going to satisfy. You can also look into the value for I and the value for n is that length. I'll leave that to you. But we know that this is not going to be true. So we don't really hit the base case just yet. So I'm going to have step over. All right, this is important. All right, let me pause slightly. The whole thing is a return something or something. In order to evaluate it, it's going to evaluate the left-hand side first, followed by the right-hand side. But the left-hand side here is going to involve the whole branch over here. That's something we're going to trace together. All right. So now we are here, 0, 0, 0. If I say step into, I'm actually going to go into this particular call. Right? That's what you're going to see. Watch out. All right. All right. Let me go back here. If I say step into, you can even see that only line number 61 is being highlighted. So that's the one we're going to execute. Right? Don't say step over, say step into. If I say step into over here, now where are we? This might be the first point you might just get lost. So what you want to see is look at the variables over here. It tells you that you're calling the split array helper by 1, 2, 0. I1 and group of sum will be 2 and 0. 1, 2, 0. Exactly here. So you can see where we have how we transition. We transition from 0, 0, 0 into 1, 2, 0. Okay? And this is not the base case yet, so now we are in step number 3. To really get to step number 4, we follow very similar logic. So I can say step over. All right, so now we are at this point here, similar. All right, let me remind you here. Remember, we are now in 1, 2, 0. At 1, 2, 0 here, we can either go here or go here. But we're going to go for the left. So if I say step into, we're going to see this one here, which would be 2, 4, 0. All right? Okay, and if I say step into, all right, 2, 4, 0. Exactly. Okay, hopefully you're still kind of following. So this will be kind of the base case we have reached, 2, 4, 0. So we are now right here. And that one there, if I say step over, I'm not going to go to the else branch anymore because I have already hit the base case. I is 2, and its length is also 2. So if I say step over, return. What should I return? You can look at the sum of group number 1, which is 4 and 0. All right, 4 versus 0. If you look at here, I got 4 versus 0. I'm going to return false. All right. What if, let me just show to you. So this, as soon as I say step over, I'm going to return this value. Now let's make some prediction. At this point, I know I'm going to return false. What if I say return? Where should I be? Should I go to here? No. What I should do is, remember this particular call was somehow suspended. Let me need my help to do some call stack quickly. And call stack, remember, is something we assume you know from 2030. Okay, let me just draw down a little bit for you. Okay, quickly. So we started with first step number 1. So that method call is put onto the stack. And we do step number 2 also onto the stack. And then we do step number 3 onto the stack. And then finally, we are now in step number 4. All right? Let's say step number 4, we know that it's going to return false. So where are we back to? 3. Right? That's how you argue. All right? So now back to here, it should be 1, 2, 0. All right, let's now be careful. So now if I say step over. If I say step over and now watch out, it's now 1, 2, 0. 1, 2, 0. Exactly over here. All right? 1, 2, 0, and then it tells you that we have just executed this left branch. That's what we have done. All right? And then if I say step into again, because this particular branch has just returned false. Let me show to you. in order to evaluate this, we tried this one already. That one returned false. That means short circuit will allow us to also evaluate this one. All right? Because if that's only false, or we'll not skip the right arguments, the right hand side. All right, so what I will do is I'm going to do another step into. Over here, step into. Now, take a guess. If I say step into over here, what's going to happen? Are we going to return? Are we going to step into something else? Yeah?
You're going to step into the same method and then hit the base case?
In the not the base case actually, but it will be another method here. So that might be a little bit tricky question, but anyway, I'll just continue. Okay, so here, since we are done with this one here, the line number 61. So if I say step into, it's going to go for the right hand side. So now here, I'm done with this. Now I'm going to the right hand side. So let's say step into. Exactly there. Okay, now it moves to the right hand side. And then if I say step into again, so now what I get is 2, 2, 2. 2, 2, 2. Over here. All right. That one there, I know is also another base case, which is going to return true. All right. We're reaching the end, but the ending part is really important. You really want to see the short circuit evaluation. So now we got 2, 2, 2. So 2 here is equal to 2. So we know that this base case is going to return true. Okay, so here, sum of group number 1 is 2. You can move your mouse over, it tells you it's 2. And here, that also tells you that it's also 2. All right, so now it's going to return true. So this particular method call over here, this one here, we know that it returns false, and this one returns true back to us. So overall, this one here is going to give us true. All right, let me go one more level. Okay, we're getting there. And if I say step over here, so now I'm back to another level up, which is 1, 2, 0. Okay, I'm now back to over here, 1, 2, 0. I know that it's going to return true. All right. And then I'm just going to step over. Okay, and that one there is just going to, that one there, but if you rewatch the recording, as soon as I say step into, it's actually going to go one level up. I tell you why. Remember what we had over here was we got false here, we got true over here, and then as I say step into, I just go back to over here because that one there is going to give me true. Okay, that's one thing you can also give a try on that. Okay. Two more things, a couple of more. So this one here about, so now we are back to 0, 0, 0, which is over here. Now, here's a critical decision we have to make. Do we have to go on to the right-hand side? We don't need to. Let's see exactly how it will be skipped at the runtime. So that'll be the last thing to do. We know that overall, this part here already gives me true. So this part should not be necessary anymore. All right? So now if I say step into, so notice that I should not be able to go on to here anymore because that one should be skipped. That's a critical thing. If I say step into, I just go to return right away. That one tells me when I was here, I know that this particular branch already gives me true. If I say step into again, I'm not going to go to here anymore. I'm just going to return whatever I got, which is true. That's how the short circuit evaluation actually works at the runtime. And after this, if I keep step into, I'll just return true all the way back. All right. So what's really important, I just illustrated. That's something I will really encourage you to really try to reproduce. I'll just highlight this one here. So this part over here is going to be skipped for evaluation because of short circuit evaluation. So this part is actually not evaluated because short circuit evaluation. Because this part over here is going to return to you just true. All right, this part here will just give you true. Okay, so if you just step into again, so now we are back to the original method here. That one's going to return true if you step into again. So now we are back to the original assert equals. And if you say step over, we are not going to get any assertion failure. Okay? So that's the complete tracing. Right? Could be a little bit confusing and very tricky to do, but give it a try. I don't think I make any mistake in terms of demo. So while you guys can really follow the recording, maybe do it again. I'll give you some quick exercise. All right, so let me recap. So for here, we try to really show you the tracing on both on the paper to really build the tree completely. And at the runtime, when we use the Eclipse, you have to watch out how exactly the short circuit evaluation is going to work. All right, that's something you want to watch out for. And also a little bit cost stack over here. All right, any question? Yes?
So for 6, we hit the base case, but for 7,
Mm-hmm.
that's just a return, right?
Just a return, yes. 6,
Everything above is just a return.
exactly. So you can think about 6 over here. We are still adding something on top of the stack. As soon as 6 is done, we remove it from the stack. And then for here, once we return from here, we also remove number, for example, 3 from the stack, and etc. Just keep returning. That's correct. All right, very good. Okay, I think at least today we can finish this example thoroughly. Okay, and then we can definitely start something new on Thursday. I do have one more thing to say about this example here to make a conclusion. But guys, any other questions about this? Right? Really play with this example here. I think there are many things you can learn from walking through this example. Why don't we take a very short break by taking attendance, and then we'll resume. All right? All right, we're pretty much done. Before the break about this split array example here, I can leave you guys alone pretty soon. There are 2 more things I want to say. Number 1, so there is another test case over there, split array 4, which is going to consider 5 to 2. So here are some assigned exercises I will suggest you try. All right. So your exercise over here. Okay, I'm going to write down what you got to do. So exercises, which is really about tracing. I want you to try to trace on the paper, which will involve you building the tree like this, like here. And then number 2, which I think is more valuable for you. Once you got that tree on the paper, you can somehow try to number the step is going to happen if you try to step into in the Eclipse. Right? You can do what I did before the break. And then I want you to also try to keep track of how exactly things will be returned in Eclipse using debugger. All right? It's going to be more complicated than what I did in the class, but if you kind of follow what I did, I think you're able to do it. Okay? It's just a matter of spending some time. Also, you're going to trace on Eclipse using debugger. All right, I'm going to release the recording later tonight or tomorrow. You can definitely feel free to follow through that simple example first before you try this exercise. All right, I'm going to leave this to you. If you got trouble finishing this, let me know. Happy to help. Okay, these 2. All right, I got about 6 minutes. I think I'll just do one more insight share, and then I'll start a new lecture on Thursday. All right, so that'll be the plan. Okay, so for this one here, I want to talk about just one more insight into this example here. So let's say we consider another more complicated example here. Let's say we got 1, 2, 3, 10, 10, 1, 1. All right. First of all, this one here should return true or false. True, because somehow you can see we got 10 here, and possibly we got, I don't know, maybe like that. So there'll be 10, 12, 13, 14, and also 14, right? Something like that. All right, so it's going to be true. So there's at least one equal split. So rather than, of course, I'm not going to trace in complete detail. Everybody's going to be bored, and I cannot do it in 6 minutes. So what I would do is I want to point out several things. You can kind of think to yourself how that's going to happen, right? So I'm going to visualize this in a slightly higher level and see how things are going to work. Okay, there we go. Okay, the input I'm going to say will be 1, 2, 3, 10, 10, 1, 1. All right, I'm going to leave this page clean for you, so you can feel free to print it out and do whatever you like. So we got 1, 2, okay, I got 1, 2, 3, 10, 10, 1, 1. All right, and I'm going to focus on just 2 parameters, only these 2. I'm only going to focus on group number 1, group number 2 sum. Okay? And I'm going to ask you guys some questions. Okay? And we're talking about paper tracing, not debugger. Okay? So the starting point will be we got 0, 0, which means I haven't really inspected any element just yet. So group sum for group number 1 should be 0. Sum for group number 2 should be 0 as well. All right? And I know that in order for me to actually go for the very first call, assuming that I'm going to go from left to right, I should actually look at element 1, right? That one there is going to give me 1 will go to group number 1, and also 1 may go to group number 2. Let's just do 1 here. So here it could be 1, 0, and here can be 0, 1. Are we good so far? All right. And of course, you know that if I want to continue, I need to, let me just go one more. I should really branch out over here. And then this part here, I'm actually going to consider maybe the element 2. That one there, 2 might go to group number 1, 2 might go to group number 2, and this one here, right? No surprise. All right, so this is my question. Imagine you're going to complete this tree somehow. And the tree is actually going to look like something like this. Okay, maybe use a highlighter. That might be the best choice. It's going to be a tree like this. All right? So this guy here is a starting point, which I call the root. Let's now think about 2 things. This could be a nice intuition about some mathematical property, which we'll see when we talk about tree. Doesn't really mean we cannot talk about it now. Think about this one here is called 1 level. Level 1. Which is level number 1 is actually going to look after this one here. Oh, you know what? Let me be consistent with the color. This one here, oh, not that green. This one here is actually going to be the level number 1 is going to look after this element. And level number 2 is actually going to look after the second element, which is 2 over here, right? And that one there is actually going to be like this. And first of all, question for you. After level number 1, we got 2 branches over here. What about after level number 2? How many branches? 4? 1, 2, 3, 4. Okay. Not too sure if you see the pattern. We got 1 here. We got 1 here, we got 2 here, we got 4 here, right? And now, let's say I'm trying to look after all the elements. I'm going to look after 1, and then 2, and then 3, and then 10, and then 10, and then 1, and then 1, right? Imagine what that's what I'm going to do. 2 questions for you. At this point over here, this is like a second last level, second last. And this one is to handle 1. Okay? Now, how many branches should there be here? Okay, let's now see some pattern here. Okay? This one here, so after looking at index 0, we got 2 to the power of 1. After looking at index 1, we actually got 2 to the power of 2, right? That's a pattern. And now this will be 0, 1, 2, 3, 4, 5, 6. So now after looking at index 6, it should be 2 to the power of 7. Agree? Which is 128. That's about how many that'll be involved. I want to show you some insight. Of course, at the bottom level, you will actually reach the base case, right? And also, you want to think about mathematically, how many calls in total have we actually got over here in total? That one there, you don't need to worry, but I want to give you some heads up. Remember something called geometrical sequence that you learned maybe in the high school? How do you sum up a geometrical sequence? That would be something to solve this. That's something we also need to talk about when we get to the trees. So what you should really get from this general insight is exactly how we can build the tree when you do tracing. Sorry. How you can do the tracing all the way from left to right. And once you get to the bottom level, how many branches can you really expect to see? I'm going to show you the pattern about how to figure that out. All right, so now we are done with this example here. Thank you. And then starting from Thursday, we'll talk about asymptotic analysis.